Welcome! Have you ever walked into a store and just felt like everything was in the perfect spot? Or seen a factory that moves with a kind of beautiful clockwork precision? Well, that's not an accident. Today, we're pulling back the curtain on the science behind that magic, facility layout and design. It is all about how you arrange things to get the absolute best performance.
So that's the big question, right? How does any business get to that state of, well, perfect operational harmony? It's a massive challenge, and a huge piece of the puzzle is something we almost never think about: the physical layout of the place.
A great way to think about it is like arranging an orchestra. When every instrument and every musician is in just the right place, you get this incredible symphony of efficiency. But if the arrangement's off, all you're going to get is noise and chaos. That's exactly what we're diving into today, the art and science of that arrangement.
Okay, so here's our game plan. First, we'll cover the absolute basics, what facility layout even is. Then we'll jump into the 3 fundamental layouts that every manager has in their toolkit. After that, we'll get into the details of actually designing 2 of them, the process and the product layouts. And to wrap it all up, we'll look at some of the really cool modern and hybrid layouts that are changing everything. Sound good? Let's jump in.
All right, Section 1. What is facility layout? This is so important because it's the foundation for literally everything else we're going to talk about today.
So let's start with the core definition. ඉතින් facility layout එහෙමත් නැත්නම් පහසුකම් සැලැස්ම කියන්නේ ආයතනයක් ඇතුලේ තියෙන හැමදේම ඒ කැලේ යන්ත්‍ර, සේවකයින් සහ වැඩ කරන තැන් පිළිවෙලකට සකස් කරන එකටයි. මේ සකස්මෙන් තමයි ආයතනයේ වැඩ කොච්චර ඉක්මනට සහ හොඳට වෙනවද කියලා තීරණය වෙන්නේ. In English, facility layout is the strategic arrangement of all the elements within a facility. We're talking machines, workstations, departments, even where people stand. This arrangement isn't just about looking neat, it's a critical factor that directly impacts how well and how fast an organization can get things done.
So why do we obsess over this? Well, the objectives tell the whole story. It's not just about tidiness, it's about hardcore performance. The main objectives are to get the most out of your space and your people, to get rid of any bottlenecks that slow things down, and to build in enough flexibility so you can adapt to changes. But let me tell you, the number one goal, the one that keeps managers up at night, is this first one: to minimize material handling costs. Every time you move something, it costs time and money. A smart layout cuts that cost down dramatically.
Okay, let's get into Section 2. We're going to break down the 3 basic types of layouts. Think of these as the fundamental tools in any operations manager's toolkit. First up, we've got the process layout. This one is all about grouping things by their function. පළමුවෙන්න ක්‍රියාවලි සැලැස්ම. එනම් process layout. මෙහිදී එකම වගේ වැඩ කරන යන්ත්‍ර හෝ ක්‍රියාකාරකම් එක තැනකට එකතු කරනවා. උදාහරණයක් විදිහට machine shop එකක lathe machine ඔක්කොම එක තැනක, milling machine තව තැනක, drilling machine තවත් තැනක තියෙනවා. මේක ගොඩක් වෙලාවට පාවිච්චි කරන්නේ එක එක විදිහේ බඩු හදන, එහෙමත් නැත්නම් batch production කරන තැන්වල. මෙහි ප්‍රධාන අරමුණ ද්‍රව්‍ය එහා මෙහා ගෙනියන වියදම අඩු කරන එක. So in a process layout, you're grouping similar activities or functions together. A classic example is a machine shop where you've got all the lathes in one area, all the milling machines in another, and all the drilling presses in a third. This is perfect for places that make a variety of different products, like a job shop or in batch production. And the primary goal? You guessed it, minimize those material handling costs.
Next up is basically the polar opposite, the product layout. ඊළඟට නිෂ්පාදන සැලැස්ම එනම් product layout. මේක තමයි අපි assembly line එකක් කිව්වම හිතට යන්නේ. මෙතනදී බඩුවක් හදන පිළිවෙලකම යන්ත්‍ර සහ වැඩපොළවල් පෙළට සකස් කරලා තියෙනවා. මේක පාවිච්චි කරන්නේ එක දිගට ගොඩක් බඩු හදන mass production කරන තැන්වල. මෙතනදී වැදගත්ම දේ තමයි හැම වැඩපොළවකම වැඩ ප්‍රමාණය සමාන කරන එක. ඒකට අපි කියනවා line balancing කියලා. The product layout is what pops into your head when you hear the words assembly line. Here, everything is arranged in a straight line, following the exact sequence of operations needed to make a specific product. It's built for speed and efficiency, perfect for continuous mass production. Now, the absolute key here is that the main goal is to perfectly equalize the work at each station. We call that concept line balancing.
And our third basic type is for those situations where the product is just way too big to move around. තුන්වෙන ස්ථාවර ස්ථාන සලස්ම එනම් fixed position layout. මේ නිෂ්පාදනය චලනය කර නොහැකි ව්‍යාපෘති සඳහා භාවිතා වෙනවා. උපකරණ, සේවයකින් ද්‍රව්‍ය සහ අනෙකුත් සම්පත් එම ස්ථානීයතම ගෙනයනු ලබනවා. මෙහිදී ස්ථාවර පිරිවැය අඩුවන අතර සාමාන්‍යයෙන් විචල්්‍ය පිරිවැය ඉහළ යයි. The third one is the fixed position layout. This is what you use for huge projects where the product itself stays put. We're talking about building a ship, a bridge, or a skyscraper. Instead of moving the product, you bring all the resources, the workers, and the equipment to the site. This usually means your initial fixed costs are low, but your variable costs can get pretty high.
So let's put the two main types head-to-head, because this really shows the core trade-off you have to make. Kriavadi salisama, NM process layout eke pradanawasia nam nishili baviai. Eda vivida nipunata edi sewigai nawashio wanaratara, travia hesiduima, vichalia marga osse siduanawa. Anika tata, nishpadana salisama, NM product layout eke wasia karekshamatawiai. Sewikainda simida nipunata tibima pramanawat wanatara, travia hesiduima, stavara marga osse siduanawa. Okay, let's break this down. The big advantage of a process layout is flexibility. You use workers with a wide range of skills, and you move stuff around with things like forklifts. But with a product layout, the huge advantage is pure efficiency. You have workers with very specific, limited skills doing the same thing over and over, and materials move on a fixed path, like a conveyor belt. It's the classic business decision: flexibility versus efficiency.
Okay, moving on to Section 3, let's talk about actually designing a process layout. And remember, the whole game here is to arrange for maximum flexibility while keeping those pesky material handling costs as low as possible.
So how do you actually do it? Well, there are two main methods, and it all depends on the kind of data you have. Palamovenna block diagramming. Mekapawichikrane apita sankhyaatmika datta ekianne departamentu atara kochara badu ehameha yanamadawagi datta tianavanam. Mehi ilakya thamai eka langa neti departamentuan atara badu geniane eka pulwang taram adu karane eka. Divanna relationship diagramming. Mekapawichikrane sankhyaatmika datta neti velavata. Metanadi kalamanakaruge adahas anuwa Mother's Grid kiana meolamak pawichi karala departamentu ekinikara kochara langinthiana onada kila thirianana karanawa. So first step is block diagramming. You use this when you've got hard numbers, quantitative data, like how many loads are moving between departments each day. The goal is simple: arrange the blocks to minimize the travel between departments that aren't right next to each other. The second method is relationship diagramming. This is for when you don't have that numerical data. Instead, it relies on managerial input using a tool called a Mother's Grid, which rates how important it is for departments to be close to each other on a scale from A for absolutely necessary down to X for undesirable.
Of course, these days, you don't always have to solve these giant puzzles by hand. Modern solutions like Craft and CorelApp are a huge help. They use powerful computer algorithms to run through thousands of possibilities and help managers find the optimal layout to solve these really complex decisions.
And that leads us right into Section 4, designing a product layout. If a process layout is an art of arranging for flexibility, then a product layout is really the hard science of the assembly line.
The single most important concept here, the absolute key to making a product layout work perfectly, is line balancing. Line balancing, NM rekha tulanai, yanu ikalas kirime rekhawakas sam wedapulakama, veda promana samana kirime tu usaha kirimai. Mihi aramunu sumuta akhanda pravahayak sahate krimai. So, what is line balancing? It's the process of perfectly equalizing the amount of work that's assigned to each and every workstation on an assembly line. The goal is to create a smooth, continuous flow, making sure no single station becomes a bottleneck while other stations are just sitting there waiting.
Now, to get that perfect balance, the very first thing we have to calculate is something called cycle time. This number is everything. Cycle time, enam chakra kalaya, nishpadanekata ek vedapolaka gatakirimata avasara diyeti uparima kalayai. E ganane karanne, pavatina nishpadana kalaya, apekshita nimeum ekaka gananin bedimenui. In English, cycle time is the maximum amount of time a product is allowed to spend at any single workstation. You calculate it by taking the total production time you have available and dividing it by the number of units you need to produce. You can think of it as the heartbeat of the assembly line. Every single station has to get its job done within that time.
So once we have that heartbeat, that cycle time, we can figure out the ideal number of workstations we're going to need. Nyayatmika avama verapala ganana soyagane, nishparaneyata adala siluma karyan sanha garavana mulukalaya, apagananeya kala chakrakalayan bidhimenui. This is called the theoretical minimum number of workstations, or N. You find it by adding up all the individual task times it takes to make the product, and then you divide that total by the cycle time we just calculated. This gives you the perfect starting point for your design, the absolute fewest stations you could possibly need to meet your production targets.
All right, let's move into our final section, modern and hybrid layouts. This is where things get really interesting, because companies are always trying to get the best of both worlds. That amazing flexibility of a process layout combined with the pure speed of a product layout.
And a brilliant example of this kind of hybrid thinking is the cellular layout. Cellular layouts වලදී සමාන හැඩයන් හොර සැකසීම අවශ්‍යකතා සහිතය කොටස් පවුල් සැකසීම සහිත විනාශ යන්ත්‍ර. සයිල ලෙස හඳවන වැඩමාධ්‍යාන් ස්ථාන බවට කණ්ඩ කරනවා මෙහි ප්‍රධාන වාසිය වන්නේ ද්‍රව්‍ය හැසිරවීම සහ සැකසුම් කාලය අඩුවීමයි. So, in cellular layouts, you group different kinds of machines into these little work centers, or cells, that are dedicated to processing families of parts with similar needs. It's almost like creating a bunch of tiny product layouts inside of your bigger process layout. The advantage is huge. You slash material handling and setup times, giving you a big boost in efficiency without sacrificing all of your flexibility.
Now let's take that idea and add a layer of high-tech automation. That's where you get flexible manufacturing systems, or FMS. FMS anamnomiyashili nishpadana paddhati, swayankriya yantra saha drovya hesaribima paddhati, bhavata karamin, nishpadana salasmaka karyakshamatava saha kriyavali salasmaka namyashili bhavaya ekabadda karanava. And FMS uses automated machines, robotic material handling, all of it controlled by a central computer to achieve that ultimate goal, combining the incredible efficiency of a product layout with the powerful flexibility of a process layout. It is basically the robotic answer to having your cake and eating it too.
And finally, there's a layout that's perfectly designed for today's customer, the mixed model assembly line.
මිශ්‍ර මාදලි එකලස් කිරීමේ රේඛාව එකම එකලස් කිරීමේ රේඛාවක ඕනෑම අනුපිළිවෙලකට විවිධ මාදලිය නිෂ්පාදන සිදු කිරීමට සැලසුම් කර තිබෙනවා. මේ සඳහා ඉතා දක්ෂ සේවක පිරිසක් සහ U-හැඩති රේඛාව වැනි දක්ෂ සැලසුම් අවශ්‍ය වෙනවා.
These lines are specifically designed to produce multiple different models in any order on one single assembly line. This is how you meet diverse customer demand efficiently. But it's not easy. It requires a highly skilled, flexible workforce and clever designs, like U-shaped lines, which help improve communication and teamwork.
And that brings us to our final question to think about. We've gone from these basic process and product layouts all the way to highly automated, flexible systems. So where do we go from here? In an age of AI and even more advanced robotics, what does the perfect facility layout even look like in the future? Will factories be completely modular, reconfiguring themselves on the fly? It's a fascinating thing to think about. Thanks for joining me.